Alright, Precalculus Concept 10D is about inverse functions. We're basically going to pull everything together now. So for any example, we should be able to look at a function, determine whether it has an inverse. If it does, find it, and then graph a function and its inverse together. So we'll start with an example. Y equals, or f of x equals 2x minus 1. Find the inverse, graph them together, and then label 2 points on each. Alright, I'm going to do the inverse over here first. Remember, we're going to start off with a y equals formula instead of function notation. We're going to switch the places of the x and the y, and then we're going to solve. So I have x plus 1 equals 2y, and my y equals x plus 1 over 2. I found my inverse here. I'm going to use inverse notation for my final answer. And it's going to look like x plus 1 over 2. And if I want to write that in slope-intercept form, it would be 1/2 x plus 1/2. I get that by distributing the two. Alright, so I have found my inverse function. What's left is to graph the two. Alright, here's the graph of my function f in red. Line whose slope is 2, whose intercept is 0, -1. I picked a couple points at random there. 3, 5 is on the graph. It also satisfies the equation. If I plug 3 into that function, I get 5 out. And -1, -3 is another point on the function. In green here, I have the inverse function. It is also a line. Notice I've got those reflected points. I left off the mirror this time, but if you wanted to see the mirror, we could show that in a different color. Should be a line that goes right down the middle and has a slope of 1. So this is the y equals x line. A good idea to show that. Usually as a dotted line, but y equals x is what your mirror is. Again, tilt your head sideways, you should be able to see that symmetry. Another thing to notice is once you found a point on one of the two graphs, you can immediately find that corresponding point. You don't have to recalculate anything. So really, even though there's 4 points to label, you're really only needing to find 2. Alright, here's another example. We're going to consider a function, this time x squared minus 1. And we're going to add in something called a restricted domain. So a restricted domain is basically looking at the function only for a certain set of values, and we often do this so that we can get around that horizontal line test failure. So let's take a look at what this graph looks like. Alright, if I were to graph x squared minus 1, we know we have a parabola that's shifted down 1. And if you think about a parabola in your head, it's definitely going to fail the horizontal line test, and therefore not have an inverse. However, if I use this restricted domain, I'm actually only going to graph the function for values greater than or equal to 0, and what you end up getting is half a parabola. So it just kind of starts in kind of midair right there, and that will pass the horizontal line test, so that does have an inverse. Alright. I'm going to graph this a little more carefully actually because I want to include the points that it would go through, so I know it goes through 0, -1. If I were to plug in 1 to that function, I would get 0 as an answer, so 1, 0. And let's plug in 2 because 2 is going to give me another point. That would be the point 2, 3. And again, I'm only looking at inputs, domain, that are numbers greater than or equal to 0. So that's my graph of f. Okay, so to find the inverse, I'm going to consider this function only for positive values, and I'm going to do the same steps. So x equals y squared minus 1. Since I've interchanged x and y, I want to now think about a restricted y, and x plus 1 is going to be y squared That's for y values that are greater than 0. And if I were to solve this, I would get plus or minus the square root of x plus 1. When I factor in this restricted y can only be positive, which means I am now only looking at the positive part of this answer. And I don't need the restriction anymore because now I've thrown out the negative part. And that becomes my inverse. So my inverse here is the square root of x plus 1. We should recognize that as a common function. Square root graph shifted to the left 1, and if I put that together and think about my points, the green graph's going to have 3, 2 on it, 0, 1, and negative 1, 0, and you can see again that f inverse and f are reflections of each other. If I wanted to show one more time that reflection line, I'll do it in yellow. I'm just going to go right down the middle there. And I have my final answer of a function. It's inverse and a couple points on each. Obviously the diagram here looks kind of cluttered there. If you have some colored pencils or highlighters, that's a helpful way to show the one graph differing from the other. Alright, we're going to finish with a u-try. I've given you a function. It's a version of one of your common functions, x cubed minus 1. I'd like you to do two things. Find the inverse of that function, and then see if you can graph the two together, labeling 2 points on each. Alright, I've found the inverse here in green and graphed that. The original graph shown in red. Got a lot of points to pick from. I picked a couple. So 1, 0, and negative 1, negative 2 are on the graph of f. And the corresponding points, negative 2, negative 1, and 0, 1 are on the graph of f inverse. Once again, we see that mirror image and the reflected points. And the mirror is through the line y equals x.